Imagine a world in which galaxies decide to call it quits and the stars cease to glimmer. What wonders might lie beyond this recently identified border? Is this just the start of a brand new chapter in our cosmic journey? Or are we on the verge of solving the greatest endless mystery? Webb cases seem to have reached the end of the universe. You read correctly. The last frontier may not be as unbounded as you think. Wait a minute, though. How could space have a limit? It was meant to last forever, wasn't it? Well, let us see what is truly going on. I was very excited to solve one of the universe's many mysteries when I first heard this news. That's exactly what the James Webb Space Telescope has been doing, and it's completely changing how we think about the universe. This wonder showed us things that left us scratching our heads and staring wide-eyed after only 12 hours of observation. All right, let's try to visualize the actual size of the cosmos. Think as far as your imagination will carry you, all the way to the edge of space. Let's now determine the precise amount of space that the James Webb Space Telescope can actually observe. Let's not waste any more time and board our non-existent supersonic spaceship. The reality is incredible. We now pass planets like Mars, Jupiter, Saturn, Uranus, and Neptune as we make our way to the solar system's edge. We are now at the heliosphere barrier after covering 100 cosmic units. Voyagers 1 and 2 have explored into interstellar space beyond this point. We are now getting close to the Oort cloud, a group of asteroids about 200,000 astronomical units from Earth. We can simply navigate through the asteroids and into total darkness because it is sparse. In a matter of minutes, we zoom past planets and stars to the edge of our galaxy. There are only bright specks of neighboring galaxies, no more boundary twists. Plotting our path, we discover that there may be other universes and that our galaxy has a limit of 10 billion light-years away. A collision with another universe could be the cause of the first supervoid, which is 1 billion light-years wide. However, how can we access these alternate universes? Perhaps the answer lies in black holes. They inexplicably distort time and reality. The possibility of white holes, the opposite of black holes, is even suggested by certain scientists. These are thought to have the potential to lead to other universes. Do you recall the 2006 Big Bang? That unexplained burst of energy could have been a young white hole, destroyed nearly instantly. Let's now discuss the Andromeda Galaxy, which is traveling at a speed of 68 kilometers per second. It won't hit us tomorrow, so don't freak out, but when it does, it will be intriguing. Perhaps our solar system is launched into dark space, like a tennis ball released on a rope, or we might see a celestial collision. In the future, the black holes at the centers of the merging galaxies start dancing. When they finally combine to form a supermassive black hole, energy is released and an active galactic center that can be seen for millions of light-years is created. Next is the South Pole Wall, which has a quadrillion stars and is located 500 million light-years away. The Hercules Corona Borealis Great Wall is a massive edifice that spans 10 billion light-years. Additionally, keep in mind the massive quasar group, which is 6.1 million times heavier than our Sun and spans 4 billion light-years. The observable universe, which consists of more than 500 billion galaxies with billions of stars apiece, comes next. But hold on, there's a void 1 billion light-years wide known as the Boötes Void, or the Great Void. Some people think it results from two bubbles contacting and ripping away material when universes collide. Imagine the cosmos as a gigantic bubble with potentially infinite bubbles. These universes might be connected by wormholes or gates inside black holes. The idea is to fold a piece of paper so that 2 points are connected without spanning the entire page. Speaking of black holes, it would be possible to survive if the influence of their enormous gravity increases gradually, preventing the feared spaghettification. You might end up in a different universe with a different physics if you survive a fall. Right now, though, it's just a wild theory. So picture yourself gazing up at the stars on a starry night. They may appear uniformly dispersed, don't they? As it happens, it isn't the case. The vast celestial web that connects worlds throughout the cosmos is made up of all those stars. What may be the earliest strand of this enormous network ever identified was recently unintentionally discovered by astronomers using the James Webb Space Telescope. I'll explain it in 2 articles that were published in the Astrophysical Journal Letters. Researchers reveal everything about this astounding discovery. They discovered a titanic ringlet made up of 10 closely spaced worlds that span an astounding 3 million light-years using data from the James Webb Space Telescope. I was astonished by how long and how tight this fiber is. I expected to find something, but I didn't expect such a long, clearly defined structure. Shani Danieli, an astronomer from the University of Arizona who is a member of the investigation team, couldn't contain his excitement. It's like unintentionally discovering a hidden ancient treasure in the enormous vault, only 830 million years after the Big Bang. Or the universe's formative years, this ancient thread of gas and stars was formed. And you know what's holding this hideous thread in place? Naturally, a really large black hole. This black hole isn't your typical one. It's a very luminous celestial body that serves as the astronomical design's anchor. The TRI project includes the team responsible for this amazing discovery. TRI, what is it? Its fancy term, spectroscopic survey of one-sided coronas in the reionization phase, is what it stands for. Their goal is to determine the impact of the first black holes on the evolution of galaxies. What brought them to this old fiber, you ask? They were aiming for one of the 5 early universe quasars. The driving force behind this, Fan Wang, an astronomer from the University of Arizona, is ecstatic. He said, "This is one of the earliest filamentary structures that people have ever seen associated with a distant quasar. It's as if they've stumbled onto a priceless treasure map that holds mysteries about the early history of the universe." The intriguing part now is that the scientists think black holes were a major factor in creating this massive web. Envision black holes acting as magnets, attracting matter with their gravitational pull. But hold on, they also use what they refer to as cosmic winds to occasionally toss objects far away. Even though the galactic winds attempt to drag these threads of stars and dust across the vastness of the universe, gravity acts as the glue that holds them together. What will happen to this old fiber? The experts, however, have a clever suggestion. They predict that this celestial string will eventually come together to form a group of galaxies, similar to the Coma Cluster, which is located around 33 million light-years from Earth. It's similar to witnessing the universe expand and produce its own wonderful work of art over countless years. The Webb telescope observed far more light and galaxies than anticipated when it focused its mirrors on an area of sky. Big, bright galaxies, not just any galaxies. Researchers are currently pondering and formulating a number of theories to explain this cosmic enigma. They each lead to fresh insights and questions, much like forks in a road. Option 1. In the early universe, stars and galaxies might have developed more effectively and differently. It is easier for stars and galaxies to form rapidly in a dim environment with few of them. The deviation from what we know is unexpected, but not entirely so. Option 2. What if extremely huge black holes, rather than stars, are the source of the brightness? Yes, we might be witnessing galaxies lighted by these enigmatic black holes, rather than a cosmos full of stars. If accurate, though, it contradicts our understanding of how many of these creatures existed in the early universe. Option 3. The most drastic scenario is that we don't fully comprehend cosmology, the recipe book of the cosmos. Though a little extreme, it has the potential to completely alter our understanding of the world. Option number 4 is the special case option. It's possible that we haven't even thought of every unknown aspect of the universe. Why is all of this important now? In other words, it's about figuring out where we fit into the cosmos and comprehending how we got here. It would be like attempting to solve a puzzle without all the pieces if we were missing something important from this story. As we continue to explore this riddle, additional questions come up. We have been reminded of the immensity of the universe by recent findings from the James Webb Space Telescope. We might have veered off course. In a recent study, scientists made headlines by asserting that the telescope had seen objects just 120 million years after the Big Bang, whether or not the Big Bang happened. Furthermore, it calls into question the fundamental tenets of the conventional cosmological paradigm. Einstein's theory that the universe is extremely old has shown to be incorrect, and it is likely that the universe is not as old as we intuitively believed. Our intuition has been deceiving us, and we are beginning to realize that we don't fully comprehend the situation. In an attempt to see deep into space, the James Webb Telescope can reach a distance of about 46.5 billion light-years. We refer to that as the Hubble circle or the Hubble sweep, and guess what? Only 450 million years after the Big Bang, the MAX 0647 JD galaxy, the most distant galaxy ever discovered by the observatory, is still located within this Hubble circle. Our cosmos now resembles a balloon, which keeps growing in size. It is not only growing, but it is growing at a far faster rate. The cosmos is expanding faster than light outside of the Hubble circle, but the circle won't keep expanding indefinitely. The observable universe has a grandiose horizon limit, which is an ostentatious word. Our boundary, the furthest we can see, is 93 billion light-years across, like a massive non-existent shell. Sorry, but anything beyond that is not visible. However, how huge is the cosmos outside our enormous shell? Well, we're not sure. Math keeps us honest when there are conflicting theories. It may be endless, according to some. The cosmos is 10 to the power of a billion times larger than what humans can see, according to some figures. However, the even distribution of cosmic microwave background radiation temperature and the dispersion of stuff in the cosmos imply that our universe might be limitless. You heard correctly, infinite. Already mind blown? We are staring back in time as we gaze into the infinite expanse of space, not only at far-off galaxies. The galaxies we see close to the Hubble circle are like cosmic fossils, remnants of a time that is billions of years in the past, rather than representations of the present. It's similar to having a time machine, only we're gazing back a very long way rather than going forward. Our cosmological model states that the entire observable universe compressed into a small point known as the singularity approximately 13.8 billion years ago. If the universe is finite, that is the conventional narrative. However, if it is limitless, as it appears to be, then the Big Bang occurred everywhere, even outside of our visible range. The initial galaxies were the universe's grand opening act, occurring everywhere, even outside of our line of sight, rather than in a particular region of space. However, the issue of what started it all is unavoidable. Who or what created the world out of nothing? At first, Einstein favored the theory of a steady-state cosmos that had been cooling for ages over the Big Bang theory. But circumstances have a way of altering people's opinions, and in the end, he joined the Big Bang movement. However, some individuals, including our friendly scientists, said that this cosmic story was more of a worldwide birth announcement than the beginning. The James Webb Space Telescope surprised us just when we believed we had the universe's tale figured out. It recently discovered the galaxy F200b45, which has the power to alter the course of time. If verified, this galaxy would contradict our cozy 13.8 billion-year-old universe theory because it is so far away. Webb has discovered galaxies that shouldn't be there, discussing the cosmic speedrun that challenges our current view of the Big Bang, where massive galaxies form only a few million years after it occurs. The telescope's discovery of early black holes, which are combining left and right and may have contributed to the growth of these cosmic vacuum cleaners in their infancy, was even more amazing. These black holes were discovered just 700 million years after the Big Bang. The field of cosmology is experiencing some astronomical chaos as a result of these discoveries. The cosmos might not have had a beginning at all, or it might be older than we previously believed. What if our universe were like that beloved book that never had a starting page? It would have been there all along, simply developing through different chapters. The concept of an infinite universe is starting to make sense as we look farther into space. What's the point of the universe appearing to be infinite in age if it appears to be infinite in size? Maybe the Big Bang wasn't the first seen, but rather an unforeseen occurrence. However, it's a big maybe, and further research is necessary. Does the energy of the eternal cosmos align with our current scientific endeavors? Is it able to explain the complex dance of Big Bang events? Cosmologists are baffled as to how much more of the cosmos exists beyond what they can see, even though there may be about 2 trillion galaxies in the universe. According to Virginia Trimble, an astronomer at the University of California, the universe has always been slightly bigger than whatever we can see. It's like the universe is playing hide and seek, and we're desperately trying to figure out where it's hiding. NASA cosmologist John Mather, who won a Nobel Prize, explains it this way: "We've already seen as far as you could possibly imagine. At the very edge, we get a brief glimpse of the luminosity from the Big Bang. But this isn't as far as it goes. The universe continues going, and we may never fully know. To solve the mystery, they are attempting to determine the universe's shape. Consider it like figuring out whether the cosmos is a flat sheet, a huge circle, or a massive saddle. Although the saddle-shaped concept isn't very popular right now, we are accustomed to a circular cosmos. This idea was dubbed a finite yet boundless world by Einstein. Nevertheless, cosmic microwave background radiation measurements in the late 1980s demonstrated that space is flat and unbent. According to John Mather, it resembles an endless piece of paper. This evenness implies that one might encounter galaxies indefinitely while traveling in any direction. This raises concerns about the limit of the universe, even if it aligns well with contemporary galactic theories. Virginia Trimble compares the challenge of figuring out if the world is infinite to figuring out whether a pizza has an edge or is infinite. This prompts an exploration of the boundary of the universe and beyond, taking into account a number of potential outcomes, such as the possibility of a multiverse. The cosmos might be a bubble in an expanding multiverse, according to some hypotheses, with an edge and distinct physical laws on the other side. Similar to how particles like the Higgs boson were predicted before they were discovered, space researchers search for a theoretical model to estimate the universe's infinity. The cosmic tale engages the public and encourages curiosity and investigation.